Welcome to the Math Magic Show. My name is Jason Davison and I would like to share with you some mathematical magic tricks. In the words of R. Kelly, it will be filmed here, fresh from the kitchen. Here's a trick to get you started. I could take a card, for example, like this. This is quite good, isn't it? And I could place it in here like this, blow it and it disappears, apparently from both hands, but it is here, it's just invisible, I can pull it out. Isn't that weird? The trick we're going to do today is a souped up version of a trick I've created. When I do this trick, I get a spectator to sign a coin like this. I then place the coin in this beautifully constructed blanket like this. And when I open the blanket out, we'll see what it is. It is a treasure map. Ooh, interesting. And basically the coin is now hidden behind one of these squares and we don't know which one it is. The coin is hidden behind one of these squares and we're going to use this pack of cards to find that coin. Now some people think a red pack of cards is best. I like to use blue. And also it's very important they're not normal cards. What I've done is I've labelled them west, northwest, northeast, west. You can see they are a list of all of Kanye West's children. They can cut the pack anywhere they like. We'll deal them 9 cards. So let's say they cut it here. I deal 9 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are their 9 cards. They give their 9 cards a shuffle, and the first card they might pick might be East. We'll put East down and we'll label it on the map here. There we go. Fantastic. We've got 8 cards left. They pick the next one. The next card they might pick might be South. We label that here. South will take us down here. Give the pack another shuffle. They pick another random card. The next card might be Southwest. So you go Southwest, which will be down here. Take another card, give the pack a shuffle. The next card might be Northwest. Northwest, literally one of Kanye West's children. Northwest will take us up to here. Fantastic, we're doing a strange circle. Got 5 cards left, I give them a mix. The next card might be South. Let's mark that on. South will take us here. Fantastic. The next card might be Southwest. Southwest will take us down here. Looks like we're heading to the ocean. Dangerous territory. At this stage, there's no way I could have predicted they would pick these 6 cards. There's no way I could have predicted they'd place them in this order. We'll make it even more random. Finish this off. The last 3 cards will go for Northeast. Northeast, fantastic. Well, that is going back the way we came. How devious. The devious spectator. Northeast is like this. 2 cards will go West. West will take us this way. Gone back up and then West. Last card is, it's another West. Thank you, Carol. That's a joke. West will take us, our last West will take us here. Fantastic. 9 random cards chosen at random from the pack. And the path that's been chosen is this one, this way, down here, up, down. We went this to the ocean, then back again, west, west to land on one square. This square is actually a pocket. And you'll notice in this pocket there is the spectator's coin. Interesting, but how did I know exactly where the coin was going to be? How did I know the path the spectator was going to take? Okay, before I start this, some of you might have realised that actually the first step to the method of this trick is that the pack of cards I used was the same 9 cards repeating over and over again. So actually, wherever the spectator cut to, the 9 cards they would pick next would be the 9 cards I've chosen for them in the stack. So those 9 cards were forced upon the spectator. What wasn't forced was the order. So to see what happens with the order, let's look at a simpler version where instead perhaps only 3 cards were chosen. In this case, Northeast west, and north. There's many different orders they could have picked these in. Let's have a look at a few examples. Here's one order they could have picked them in. They could have picked them in north, east, west, north. And if we add those vectors, they're called, if we add them together, we get northeast, west, north. And you will see from the start position, we've just gone up 2 squares. Effectively, we've done the vector of just going north by 2 squares. Or they could have done a different order. They could have swapped them around and gone west, north, northeast. So from where they start, they would go west, north, northeast. But again, those vectors add together to make the vector of just going 2 north, 2 squares north. Or they could have done a different order, north, northeast, west. If we start from somewhere and go north, northeast, west, again, we end up just 2 squares north of the beginning. The sum of these is the vector that just goes 2 squares north. And this is the same with the 9 cards I used. It doesn't actually matter which order you add vectors in, they will always sum to the same total vector, just the same as if it doesn't matter what order you add numbers in. 3 plus 4 plus 9 is the same as 9 plus 4 plus 3. They will still sum to the same answer. So that is how this mathematical vector trick works. I'd like to try and post one video every month. Thank you for watching. Hope to see you soon.